Welcome to Science Unplugged, the podcast where science and conversation collide. Join us for a deeper look into the world of innovation. We are your hosts, Charvi Trivedi.
And Taslima F. Farooq. Let's explore the insights from the world of science. From the lab to the field, we'll dive into the stories and experiences of researchers, experts, and innovators who are shaping our understanding of the world. Welcome, ma'am. Dr. Himadri is a postdoctoral
Hi,
researcher.
Taslima and Sharon.
Welcome, ma'am. Uh,
Dr. Himadri is a postdoctoral researcher in the Adaptive Quantum Optics Group at the University of Twente. She designs and develops next generation photonic integrated chips for quantum secure authentication and communication, turning fundamental physics into real world security solutions.
yeah.
Thank you, Taslima, for that
Um,
introduction.
so, ma'am, could you explain what adaptive quantum optics is in simple terms? Because I think this is something which I have heard for the first time. And also, what does your research group at the University of Twente, if I'm pronouncing it correct, what does it focus on?
Okay, cool. So, adaptive quantum optics. So, basically, my background has been in optics and photonics in general. I did my PhD in photonics, and what I study is basically trying to control the transport of light. Like, I try to basically dictate, hey, light, you gotta go here or wherever. Adaptive word is essentially that. Adaptive means you are essentially controlling how you want to propagate the light, and that is done by utilizing certain like components like waveguides, such as like using modulators. So all these things comes in the umbrella of adaptive. And quantum is when the light that we talk about, we're talking now in case of like single photon level instead of operating at massive scales of like billions of photons. When we reduce it to the quantum level, when we say it, it's a single or one photon. So adaptive quantum optics is basically controlling single photon flow of light. It's on chip.
So that is something which your research group is currently focusing on, right?
That's the that's the title of our group, as in, yeah, that's what our group is called. And what we currently focus on is essentially trying to, first of all, establish quantum communication channels in real life, as well as we also try to basically make next generation chip for the quantum secure authentication purposes and encryption purposes. So that's what the group focuses on. Apart from that, given that our group also has subgroups within, part of it also works on quantum computing. Me precisely, I'm in the quantum secure authentication part. Yeah.
So, as we've just established, you work in University of Twente. So, what inspired your shift from India to Twente? Like you were working in a TIFR in Mumbai. So, can you share your journey as a postdoctoral researcher at the University of Twente?
Okay, so I mean, in general, a human being always wants to progress in life. So, so that's what motivated me to essentially like transition from where I did my PhD from, that is TFR, in the field that I did, which is in photonics, to go somewhere where lies the next what's next in the field. So that's for me, the choice was essentially to get into the integrated optics, integrated photonics platform, get into the field of quantum optics, get into knowing about how to like develop chips, make chips, because well, that's where the world is at right now, and that is the demand for the future. So to that end, the choice was quite yeah, right there for me. As in place wise, yes, the Netherlands and University of Twente is a very entrepreneurial university. It's unlike any other research group where it's basically the fundamental research meets the application part. And here you have a plethora of companies that you can basically engage with time to time. So it's a very harmonious culmination of all these things coming into play, which is what I had visualized and envisioned myself to be working on. So to that end, the choice was pretty clear for me.
That's very inspiring to hear about. Uh, so, what are some of the potential?
That's quite, yeah.
Yeah, go on.
Yeah, so you mentioned that like your research right now and what you are producing is in demand currently. So can you just briefly tell us that what are some of the potential real world applications of your research and something like what we might see in the next 10 to 20 years of scientific research in this field?
Sure. So, to tell you very briefly and very impactfully, we all are aware of the fact that the world is moving into the quantum computer generation right now. So, what we do is comes under the umbrella of post-quantum cryptography. Well, what does that mean? That means that whatever encryption or the cybersecurity methods that exist right now, once the quantum computer is into play, they would render useless. As in, we basically right now the current security, like the passwords that we share online and everything, it is the security methods such as RSA. They basically rely on the fact that you have a very huge prime number and that needs to be factorized. And right now, the classical computers, in order to do that factorization, would take like billions of years. So that is what is the current security method is based on. But once you have the quantum computer, they would be essentially be able to solve that within like fractions of like seconds or even less. So to that end, what we propose are basically post-quantum cryptography. So we are basically trying to make these encryption keys, encryption methods, which would replace the existing cybersecurity methods, and that the quantum computer won't be able to crack because they are also based on quantum mechanics. So that's like the easiest way I can put it to you.
Also, just coming back to a very, very basic question, which I should have
Yes.
asked before, what exactly is cryptography? Like, how can we describe it, and how can we make people understand what
Okay,
cryptography is?
sure. Sure. So, cryptography, just to give you a very basic visual, is basically sending messages secretly. As in, like, if I want to send you a message, but I really do not want Taslima to know what I'm sending you. So, basically, what we want to do, first of all, you and me will establish a way in which that is only known to us, that hey, I can replace like every letter in your name to every third letter in the alphabet. Like we would basically try to follow certain security rules which is only established between the two of us and the third person wouldn't know, and that's how we encrypt a message, right? So the cryptography, encryption and everything is basically how to make or use a secret way in order to transmit a message. And all these things that we are doing, that's it's like the fancy way of doing that, because well, this thing of shifting every letter to the every third letter, that anyone can crack it, right? Like because anyone, if they look at it for long, they're like, oh, okay, I see that this is the method. So so right now the thing is like, how complicated can you make that process? So to that end, we have essentially reached the quantum level where you use single photons so that nobody is able to crack it.
Thank you for explaining that. Since we are not from this field, we are also lost to what it actually means. Ma'am, you mentioned that you would like to share some images as well. So let me know whenever you want to do that, please.
Oh yeah, that's basically I was thinking like when you do ask me about the experimental aspect of my
Sure.
work, and also then I can yeah, show you. Yes.
Okay, so coming back, we know that quantum computer, that is a term that we've been hearing frequently nowadays. So speaking about quantum computing and quantum communication, how does your work in adaptive quantum optics differ from these quantum other aspects of this quantum physics?
Okay, so my work, well, it is towards building a quantum future for sure. So one way I can say that is different in terms of what it is there already is basically when we are talking about incorporating the encryption method, what right now exists are like software based encryption. Okay, so basically, when you are trying to send in whatever, like even in WhatsApp, even like this message that we are trying to send in, these are all like software-based encryption that is going on online. What we propose in order to do the secure authentication, wherein it should be like I am actually trying to talk to you, Thalsima. I'm not Thalsima, not somebody else. But how do I know that? So to that end, what we do is we are making a chip through which if we transmit light and the light would be basically be able to be reconstructed the way we want only by that chip. If somebody tries to make a chip exactly like that, they won't be able to do that. Why? Because of the fact that the chip is so small and the designs that we make in them are so small that it is fabrication limitation in itself. So when we fabricate it, you would never be able to fabricate two identical chips. So to that end, that is one of the ways in which we can always ensure that the person we are sending in is unique. And it is actually the same thing which are also used in your regular every digital devices that you have, which do have a microprocessor in them. They are known as their unique fingerprints. They have their unique fingerprints because of the fact that the chip have these differences in that nanoscopic scale, because of which no two processors fingerprint would be the same. But what we are doing, we are basically now be transmitting light through it in order to say encode a message, so on and so forth. Yeah.
So that is what adaptive quantum optics does, and like quantum computing is something a bit different from that. Okay.
Adaptive quantum optics has quantum computing as well.
Okay.
The other thing is quantum security. Okay, given that you have
Okay.
a quantum computer, you would need quantum security. Okay, so these are like the
Right.
two aspects that are being dealt with. Okay, so
Right.
quantum computers are used to say like, solve problems or whatever, but also you need a quantum channel in order to do the communication
Mm.
between like, two
Mm-hmm.
parties or whatever. So in order to establish that that channel is secure, you need some encryption method, and that's where we
Okay.
come in. We have to ensure that yes, the two parties who are trying to connect with each other are indeed the two parties, and it's
Mm-hmm.
not a
Mm-hmm.
eavesdrop which is trying to steal data or whatever. And to that end, we are utilizing hardware keys which are like these chips in order to realize this and establish this communication channel.
So as we've just established, you work in University of Twente.